Okay, fixing bugs. So fixing bugs sounds like something you do all the time, and if you're like me, until a small number of years ago, you'll probably realize that you've been doing it completely wrong. Dave and I went around to a bunch of software companies that are the kinds of companies that many of you would love to have jobs at when you graduate. You know, they're companies whose software is changing the world. And they gave me a very consistent message about, one of the many things we asked about is the processes by which they do their software engineering, not their programming, because we know that people can do programming. We asked them what are the processes that let them build good software. One of the things they have to worry about is what happens when a bug is discovered, because even the most competent software companies do occasionally have bugs. They all basically came back with the same thing. This is what it amounts to. If there's not a test, you haven't fixed the bug. If you remember nothing else from this lecture, remember this. But I want you to remember more things from this lecture, okay? So we've come up with a helpful 5 R's, which is helpful only if you can remember 5 words beginning with R. It's not really an acronym. But a bug is reported somehow. Then whoever is in charge of owning that bug has to either reproduce the bug or reclassify it in a way that means it won't be fixed. Then you have to create a regression test, which is basically an executable way of demonstrating that you understand why the bug happens. Once that regression test is in place, you can then repair the bug and verify that the previously failing test that demonstrated it now passes. And finally, once you have repaired the bug, you can release the fix. And the semantics of release depend on your organization. In some cases, the bug is considered released when you have committed and pushed it to the golden repo. In other cases, for software as a service, the bug may not, or the fix may not be considered released until it actually gets deployed in production. And by the way, as when we start talking about maintenance and operations, you might say, well, does that mean that when I push a bug fix, it might languish for days or even weeks before it actually gets into the production environment that real users are using? At a lot of companies that you've heard of, including GitHub, by the way, they do several releases per day. So a bug fix that has been pushed is going to get into production really, really fast. It's one of the many benefits of extreme programming. And by the way, even though Agile processes pretty much universally use some version of this process, plan and document and non-Agile organizations more or less do the same thing. The timing of the steps may be somewhat different, but the basic concept that there's no bug fix without a test is absolutely common to both Agile and non-Agile organizations. So the big difference is, in our opinion, that you can already use the Agile processes that you know, for example, the user story-based and TDD process, and the measuring your progress with velocity and so forth. You can adapt all those processes to fixing bugs. So here's how. You start with reporting a bug. Where would you report a bug? I know there's a lot of open source bug tracking systems out there, but before you go spending a lot of time setting one up, consider using a tool you already have. Pivotal Tracker allows you to designate something as a bug, which means, among other things, it's worth 0 points as a story, which makes a lot of sense because if it was worth some number of points, then you'd be getting double credit, once for writing broken code and then again for actually fixing the broken code to work the way it was supposed to. So you can enter a 0-point story, but you can track that story just like any other. It can be in the icebox. It can be part of your backlog. And in fact, there's one of the nice features of GitHub is the idea of service hooks, which is basically whenever you push new commits to a GitHub repo, you can arrange for various other web services that developers use to be notified of that fact. And one of the commit hooks is that if you tag a Git commit in a certain way with the name or ID of a user story in Tracker, then when you check in, when you push that to GitHub, it will automatically mark that story as completed in Pivotal Tracker too. That's just one of the many awesome Git commit hooks. We'll talk about others when we talk about continuous integration. GitHub also has an issues feature. So if the Pivotal Tracker functionality isn't good enough, or if you want other people besides the development team, usually the development team is the only people who can see the Pivotal stories. But if you have your stuff in a public repo on GitHub, that's something everybody can see. So that's using the issues feature on GitHub is a way that you can get global visibility and allow other people to sort of freely report bugs. If you really need a full-featured bug tracking system, something like Bugzilla is probably fine. It's open source. So the moral is use the simplest tool that would work for your project. You can always upgrade later. It's kind of, it makes you feel good to spend a lot of time setting up a bug tracking system, but in most small projects, you shouldn't really need to do that. So that's the reporting step. The next step is reclassify or reproduce and repair. So once you've confirmed that, yes, somebody actually observed this behavior, this appears to be a bug, one possibility is that, well, this is really not a bug or it won't be fixed because, for example, it's on a branch that is now dead because we've overwritten that file with a completely different version of that class. So the specific bug you're talking about doesn't exist anymore. That code is gone. Or maybe you're using an unsupported version of the browser, or you're using Internet Explorer 6, heaven help you, and in fact this isn't a bug. The bug is that you're using IE6. So that's one possibility. The more common possibility, if it's a real bug, is the next step is to reproduce it. And this is usually the most difficult part of the bug fixing process, and rightfully so, because the goal is to reproduce it with the simplest possible test that will demonstrate that you understand the conditions that trigger the bug. And then once you have that test, you can add it to your regression suite so that this particular bug never comes back. So what does the simplest possible test mean? Well, certainly whoever ran the application and reported the bug, that's a test, right? They logged in, they did some actions, and after about a minute, something really bad happened. But that's kind of not a very simple test. You want to circumscribe the bug as tightly as possible. So kind of in RSpec terms, what is the minimum number of preconditions or mocks you'd have to set up to be able to trigger the bug? Or in user story terms, if you think of the bug as being triggered by a sequence of user actions, what's the minimum amount of stuff you could put into the background or the givens to set up the preconditions that absolutely are necessary to cause the bug? That's how you really know when you're sort of have the bug cornered. So what does repair mean? It has a very specific meaning in this context. It means you have a test that fails when the bug is present, and that same test passes when you believe the bug has been fixed. That is the only definition of repair that most software houses consider acceptable for fixing a bug. If you fix the bug and there isn't a test that fails before and passes after, then you haven't really fixed it, because you haven't proved that you can automatically reproduce the conditions that would have caused it to occur. And once you've done that, releasing it is usually easy. It might just mean that you have to push it. It might mean you notify the production team so that they get it out to production. But the idea of no bug close or no bug fixing without a test is really the central concept in all of this. Having said that, suppose you discover that, to your horror, your most recent release, which is out there in the wild, contains a bug whose regression test requires extensive mocking or stubbing because the code where the bug is located is so bad that you're going to have mock train wrecks and all kinds of bad stuff. The tests are going to be super ugly. So which courses of action, if any, would not be appropriate? One is, okay, I will bite the bullet. I'll do the refactoring. I'll use my full TDD arsenal to do that. And then the bug is going to get fixed, and I'll push the fix as new code, including those tests. I could bite the bullet and do refactoring using TDD on a different branch, push the bug as new code there, and then cherry pick the fix into the release, if appropriate. I can create a regression test and bite the bullet and set up all the mocks and stubs, have the test just be ugly, and admit that it's ugly because my code was bad to begin with. Or depending on project priorities, any of the above might be a reasonable thing to do. So which of these would be an inappropriate course of action, if any?